Got it. And got it. Okay. All right. So new share my screen. Where's the PowerPoint? Are you not able to see my screen here?
No, it just looks like it says auto joined by computer.
Yeah. Why is that? That is stop sharing. Okay. Then share screen. Entire. Thought it was working earlier, and now I'm putting my screen. There you go. Okay. Is it working now?
Yep.
Okay. And I am recording, I believe. So let's get started. So again, let's try to finish up this chapter on solutions. After the class on Tuesday, did you get a chance to look at any of those medicine bottles with the liquid? Like,
yeah, I meant to grab one.
Okay, no worries. But so there are essentially 4 different ways of expressing concentration. Okay, so now we're just going to be expressing concentration in 4 different ways. One is weight over volume expression, and most of them, 3 out of the 4 are expressed as percentages, which just means that you express, a ratio and then multiply it by 100 to get it in terms of 100%, right? Because it's easy to track it that way. The first one is the mass of the solute. Just for recollection, solute is usually the one that is getting dissolved, which is usually in the smaller quantity, and the solution is the combination of the solute and the solvent. Okay, the solvent is usually a liquid. Solute can be a solid, liquid, or gas. So this first way of expressing the concentration is weight over volume. So the numerator, the W, is actually indicative of how much mass of the solute is there, usually expressed in terms of grams. And the volume, which is the denominator, and keep in mind, this is the volume of solution. So when you add a solute to a solvent, the mixture is called the solution, and you're measuring the volume of the solution, not the solute or the solvent. Okay. So, and that volume of solution is usually expressed in terms of milliliters. So grams per milliliter times 100% gives you the weight per volume percent. That's one way of expressing concentration, and this is usually what is there in those medicinal bottles when you're looking at Pepto-Bismol or cough syrup or any of those liquid-based medicines that you look. They usually would express weight over volume. So when you guys get a chance, please look into it. Okay, so how do you do this? Vinegar contains 5 grams of acetic acid dissolved in 100 milliliters of solution. So the acetic acid concentration is 5%, weight per volume. Why is it weight over volume? Because it is saying 5 grams of acetic acid in 100 milliliters of solution. So weight over volume percentage is 5 grams acetic acid, the solute, and then in the numerator, 100 milliliters of vinegar solution in the denominator times 100%. And when you do that math, 5 over 100 times 100 gives you 5% concentration. And as I mentioned earlier, note that the volume is the final volume of the solution, not the volume of the solvent added to make the solution. Okay, how do you do this in the lab? You kind of use a special instrument called as a volumetric flask. It's basically a conical thing at the bottom, as you can see over here. And this is a plastic bottle with this pointed tip. Okay, these are very specific to a chemistry lab. If you go to any chemistry lab, you will kind of see this. This is called as a conical flask or a volumetric flask. So you take the weight, this powder that you see, this is acetic acid. You go and measure it in a scale and take 5 grams and then put that solute, that powder, into this volumetric flask. And then what you do is you keep on adding. This volumetric flask is pre-graduated from the manufacturer. It comes, there is a little graduating mark over here. This has usually got 100 milliliters. Uh, so then you keep on adding things until you reach that graduated mark over here, which is 100 milliliters. And now the combination, the solute and the solvent is usually water in this case. You keep on adding it until you reach that 100 milliliter mark for that graduated cylinder. And then not graduated cylinder, the graduated conical flask. And there now you have 5 grams in 100 milliliters to give you a 5% solution. There is extreme precision required in these things when you're making a chemical solution. You want it to be very accurate for multiple reasons, because the quality of the experiments, you don't want it to be 5.5 grams, you don't want it to be 4.5 grams. So, and if you put 5 grams, but you only do 90 milliliters, the concentration changes, because now it is 5 divided by 90 times 100. So the concentration is obviously different. So the formula is weight over volume. Always make sure the grams of solute is in the numerator. The milliliters of solution is in the denominator, multiplied by 100%. Okay, so let's look at another example. This is a sore throat spray. That's why you kind of keep coming back to these medical examples, the medicine examples. This medicine is called Chloraseptic. That's the active ingredient. So the question is asking, what is the weight per volume % concentration of phenol? Okay. So the active ingredient is Chloraseptic. Okay. So you're taking 0.35 grams of this antiseptic phenol dissolved in 25 milliliters of the solution. What is the weight per volume? It's a simple math. You just take 0.35 grams, divide that by 25 mils. But in order to do weight per volume, you have to multiply it by 100%. So 25 goes in 100 4 times. 4 times 0.35 gives you 1.4. And the strength or the concentration becomes 1.4% weight over volume. You have to absolutely mention what are the units you're tracking. Simple. Now let's do the second way of expressing the concentration. Now it is volume over volume %. So obviously when you're looking at V over V, it's a simple concept that now the solute, the numerator is a solution. And the most easy way and the common way of measuring the solute when it is a liquid is in terms of volume. Okay, so that's why you just change the numerator W in terms of volume. So now you take the volume of the solute, which is in milliliters. Again, the solute is the one that's in the smaller quantity. And then you have the solution, which is the larger quantity, which is the combination of the solute and the solvent, multiplied by 100% to give you volume over volume percentage. Let's look at rubbing alcohol. This is again a very common disinfectant that you can find over the counter in Walgreens or CVS. So now the active ingredient is true propanol, which is an alcohol. So you have 70 milliliters of the alcohol in 100 milliliters of solution, which is basically 70 divided by 100 multiplied by 100. The 100 and 100 gets canceled, and you get 70% volume over volume. If you remember, this was a big deal when we were having the beginning of the pandemic. Most sanitizers, hand sanitizers, FDA came up with a ruling that in order for it to disinfect COVID virus, it had to have a minimum alcohol strength of 65%. So if you had a rubbing alcohol or a sanitizer that was 60% strength, it would not have met the FDA requirements. Do you know what I'm talking about, Drew?
I mean, not really.
Yeah, this was a big deal back in the day in 2020 when the pandemic started. I mean, this was a big deal because there were so many manufacturers who were trying to come up. Remember the big hand sanitizer and the toilet paper shortage in the country and the world?
Oh, yeah.
Right.
Yep.
So at that time, every manufacturer was trying to make money, right? All you had to do was create a hand sanitizer product, and you could possibly be making millions at that time, right?
Yep.
And at that time, so in order to regulate it, there were some concerns, and that's why FDA came up with that. You cannot just come up with anything. You have to at least have, it had to be FDA approved. And one of the ways FDA was approving it was measuring the alcohol content, and it was minimum required to be 65%.
Yep, I remember that.
Yep.
People were buying stuff that it was burning their face and burning their skin. And
correct, exactly. Yep. So when you take any, you go to any reputable hand sanitizer, it will again have the content, but this time it will be expressed as V over V to express milliliters of solute over milliliters of solution. Okay. Another example, wine. A 750 milliliters of bottle contains 101 milliliters of ethanol, which is the main ingredient coming from the fermentation of the grapes, right? So what happens is you have 101 milliliters in 750 milliliters. So how much would be there in 100%? And how do you do that math? 101 divide that by 750 milliliters gets canceled. 750 times 100, you get 14% alcohol. If you're tracking the alcohol content in beer, usually it is somewhere between 2% with the Miller Lite or the Coors Light, 2 to 2.5, maybe 3%. And then some high strength IPAs have alcohol content about 7.5, 8%. You want even more alcohol content than 14%, then you go into the category of spirits, which are distillate products. And now you're looking at anywhere from 20% all the way up to 35, 40, even 50% alcohol. I don't think you get 50%. Yeah, I think you can get up to 50% alcohol. I think there's some vodkas that are, I think, going up to 48, 45%. So, but the concept is how much of the alcohol is there in the solution, and then you multiply that by 100%. So this is, oh, there is more. Saline solution. So we talked about this when people cannot take oral fluids because they're not able to keep their fluids down. So 0.92% weight over volume. Okay. So now they're giving you the concentration. Now they're asking you to find out how many grams of the NaCl, the solute, is there in 250 milliliters of the solution. So it's a reverse calculation. 0.92 means that you have 0.92 grams per 100 milliliters. So how much is there in 250 milliliters? You simply set up the ratio. 100 milliliters contains 0.92, or 0.92 is there in 100 milliliters. Use this conversion. And 0.92 is there in 100 milliliters according to that weight over volume that is given in terms of percent. You are given 250 milliliters of the solution. So when you do the math, you're left with 2.3 grams of sodium chloride. So it's just calculating that quantity of the solute when the percentage is given in weight over volume percentage. So now it's a reverse of the volume over, oh, this is the same. What volume of a 5% weight over volume solution of ketamine contains 75 milligrams? So now they're asking you to find the volume of the solution. Collect or gather all the given pieces of information, and then now you're required to find the unknown quantity, which is the volume of the solution. So the concentration is given to be 5%, 5 grams over 100 milliliters, or 100 milliliters contains 5 grams. So you use this conversion, and then you also have to go between your given in grams. Remember that the weight over volume is usually milligrams in milliliters, right? So now you have to convert the grams to milligrams. 1 gram contains 1,000 milligrams. So you can say that 5 grams of the solute is there in 100 milliliters, or 5 grams is the same as 5,000 milligrams is there in 100 milliliters. So how much is there in 75 milligrams equivalent is equivalent to how many milliliters of the solution? So 100 milliliters is there in 5 grams, but each gram contains 1,000 milligrams. So grams to milligrams conversion needs to be used. Grams and grams gets canceled. And then you have 75 milligrams. Convert that into equivalent milliliters of solution. You get the answer as 1.5 milliliters. So it's again just manipulating it back and forth in terms of what you're trying to find out. Questions?
Nope. Same thing, just backwards.
Yep, exactly. Glad you're recognizing that. Cool. All right. Now, the third way of expressing concentration, it's parts per million. This is something that you may have heard. This is very commonly used in air pollution. This scale or this methodology is used generally when the solution contains a very small concentration of the solute. Okay, so the concentration, as the name suggests, it's how many parts of the solute are there per million parts of the solution. Okay, and usually the numerator is extremely small, the denominator is 1 million, and you're just expressing it in that ppm scale. Okay, parts per million is the number of parts in 1 million parts of the solution, number of parts of the solute. And in this case, because the denominator is such a huge number, 1 million, right? Usually it doesn't matter whether you express it as mass or volume units. Okay. So seawater contains 1.3 grams of magnesium ions in 106 grams of solution, 1.3 ppm of magnesium. Okay. What this means is mass of solute is 1.3 grams. All right. I think it's, let's look at the scale. Oh, okay. So you can either use the mass of solute over the mass of solution, and then remember to multiply it by 10 to the power 6, because that's what is the scale for parts per million. Or if you want to use the volume scale, make sure the numerator and the denominator are in the same scale, volume of solute, divide that by volume of solution times 10 to the power 6. 1 second, my phone is almost on the verge of losing its battery here. So let's go. Is the audio and video still working, Drew?
Yep. No, we're good.
Okay. So in this case, now you are looking at the 1.3 grams is there in 106 grams of solution, right? So 1.3, divide that by 106, and when you multiply it by 10 to the power 6, the 1.3 over 106 becomes essentially 1.3 ppm. Okay. DDT. Do you know what was DDT back in the day?
No.
DDT was a very commonly used commercial pesticide.
Oh, yeah.
Right?
Yep.
And the newer generation may not be familiar with it because DDT was actually banned, I think in the early 2000 or late 1990s. I can't remember the exact time. Oh, never mind. It says it has been banned from use in the US since 1973. I was wrong. It was much earlier than, but you have heard of it, right? DDT was
they killed mosquitoes with it, and kids were playing with it in the water. And
yep, exactly. So what happened is agriculture, which is one of our very critical components of our society, right? Farming and agriculture, I mean, they were using this as a pesticide to kill all the pests and the locusts and all kinds of bacteria things. I mean, all kinds of things. I don't even know what was going on, right? But it was a very cheap available product, and it was a chemical. And what was happening is that it was starting to become an environmental pollutant. It was fixing one problem in terms of killing the pesticide, or sorry, acting as a great pesticide, but it was also leading to health issues. How? Because what would happen is that these things would not be biodegradable. And when we wash it from the vegetables, like if you grow a lettuce, or if you grow some corn, or if you grow some potatoes, and this DDT was used as a pesticide, most people wash their vegetables and they're produced before they eat it and consume it. But these things are so sticky to the product that they would not get completely washed away. And then when you start eating it, especially, in the raw form, you are basically ingesting it. And then that was a toxic thing for the human body. How they discovered is that, they used sample sets in which they were able to look at the tissues of a seabird. And some of these numbers were 50 milligrams of DDT in 1,900 grams of tissue. Okay. So again, keep in mind that you have to have the same units, right? So 50 milligrams of the DDT is there per 1900 grams of tissue. So don't forget to convert either the numerator into grams. So you can either convert the milligrams into grams. So 50 milligrams would be 50 divided by 1000, which is 0.05. And the denominator is already in grams, or you can convert the denominator into milligrams. So multiply the 1900 by 1000, you should still get the same answer, right? So 50 milligrams in 1900 times 1000 in the denominator is a huge number. That's why you multiply it by 10 to the power 6, and then that 10 to the power 6 kind of converts it into a more manageable number, and you get 26 ppm of DDT. Or you can convert the 50 milligrams into grams. As I mentioned, by dividing it by 1000, you get 0.05. 0.05 grams of DDT per 1900 grams of tissue. Now the denominator and numerator are in the same units. Don't forget to multiply by 10 to the power 6. You get 26 ppm. Easy peasy.
So parts per million is always going to be 10 to the power 6.
Exactly. Yeah.
Okay.
The million is 10 to the power 6, right? So
Oh, that makes
again,
sense.
if you don't do the 10 to the power 6, divide 0.05 by 1900, you will get 0.00026, which is kind of awkward to kind of talk, right? When you're saying, but you can easily say 26 ppm, and that parts per million implies that you have 10 to the power 6.
Yep, got it.
Cool. All right, so those three are the elementary units. We're going to be focusing extensively on the fourth unit, which is molarity. Molarity is nothing but, again, the numerator is expressed in terms of number of moles, and the denominator is expressed in terms of liter of solution. Okay, so this is, again, all you're doing is changing, then manipulating the units in the numerator and the denominator. So molarity is a very specific type of units of concentration, in which you basically calculate the number of moles of the solute, which you know how to do by using the molar mass, then take it, divide it by liter of solution, and then you get the molarity. So an example is a solution that is formed from 1 mole of NaCl to give 1 liter of solution has got a molarity of 1 capital M. Okay, now let's look at some examples. A solution that is formed from 2.5 moles of NaCl in enough water to give 2.5 liter of solution is also 1 molar solution. Both solutions contain the same number of moles per unit volume. So if you have 1 mole of NaCl in 1 liter of solution, the concentration is 1 molar. If you have 2.5 moles in 2.5 liters, again, 2.5 divided by 2.5 gives you 1 capital M, or 1 molar solution. If you have 100 moles in 100 liters, it's again 1 molar solution. Are you tracking that?
Yep.
Okay. Now let's change the denominator or the numerator and then see what happens. Calculate the molarity of a solution made from 20 grams of NaOH in 250 milliliters of solution. So the problem specifically asks you to calculate the molarity, which is a unit of concentration. First of all, identify the known quantities and the unknown quantity. They're given you 20 grams of NaOH. They're given 250 milliliters of solution. They're asking you to find capital M for that concentration, okay? So the first thing is you have to convert the 20 grams of NaOH into equivalent number of moles. How do you do that? Use the molar mass. So 1 mole of NaOH measures sodium 23 grams, oxygen 16 grams, hydrogen 1 gram. So 20 plus 16 plus 1 is 40 grams. The molar mass for sodium hydroxide, look at the periodic table, is 40 grams. If it is given, it's great. If it is not given, don't fluster. Just go to the periodic table, add the individual number of atoms. Don't forget to account for the right number of atoms. If it has got 2 atoms, then multiply it by 2 for that element weight, atomic weight. Account for it, get the molar mass. So sodium hydroxide has got a molar mass of 40 grams. you're given 20 grams. So what is the number of moles? 20 divided by 40, which gives you half a mole of sodium hydroxide. So half a mole, you just converted the 20 grams into equivalent number of moles, which is half a mole. But that is dissolved in 250 milliliters of solution. You need the concentration expressed in 1 liter of solution. So that's why you have to multiply it by 1 liter, which is the same as, again, unit conversion. 1 liter contains 1000 milliliters. So half a mole or 20 grams is there in 250 mils. How much is there in 1000 mils? Simply a bunch of conversions. So 20 grams and 40 grams gives you 0.5 moles. 250 into 1 liter divided by 1000 milliliters gives you 0.25 liters. So you had number of moles that you just calculated. The volume is calculated. You converted that to 0.25 liters. So half a mole in 0.25 liters gives you a 2 molar concentration. Again, it's just a game of manipulating different units, making sure that you're understanding that the capital M, the molarity, is always number of moles in liter, not number of moles in gallons, or not number of moles in milliliters, or not number of moles in cubic feet. If any of these other things are there, you have to get it converted back into liters, and you have to convert the grams or the pounds into equivalent number of moles, and then you calculate number of moles divided by liter to give you the molarity. This, in the chemistry world, this is by far the most technical approach, because again, why? When you're doing a chemical reaction, it is very easy to track everything in terms of number of moles. Right? Hopefully now with the reinforcement, we've been learning number of moles in chapter 5, chapter 6, chapter 7, and now chapter 8. Questions, concerns, confusion?
No, I'm good. As you were explaining it though, your slide was on like the DDT thing. So I'm following along with the other PowerPoints, but
Oh no kidding. I mean, now what do you see?
I see problem 8.9 in parentheses 2.
Oh, that is bizarre. I am
So
changing it
you're
to...
on slide 87, but I followed along. I mean, you're on, you're supposed to be on slide 90.
I am way ahead, man.
Yeah, but what we see is slide 87.
Sorry, let me thank you for bringing that to my attention. Technical glitches here. Thank you for bringing that to my attention. Let me see if I can do it again.
Yeah, because about halfway through, I'm like, what are you're talking about something that's different on your screen.
Now nothing is seen, right?
No, nothing. I see the back of your laptop.
Yeah. Oh, that I can change. Oh, that doesn't make sense. Don't. Okay, now you should see me. Okay, is this any better?
Yep.
Okay, thank you, Drew. Again, I apologize for the technical difficulties. This is not going according to the script today.
No, you're perfectly fine.
So 20 grams convert that to 0.5 moles again. Now convert the 250 liters to equivalent liters. In molarity, you have to express it in terms of number of moles, divide that by number of liters, and that's how you get the 2 molar solution. Okay, let's keep going. There's a few more practice problems. What is the molarity of an intravenous glucose solution prepared from 108 grams of glucose in 2 liters of solution? You're given 108 grams of glucose, so you know that you have to convert that into equivalent number of moles. You're given 2 liters of the solution, and you're required to find the concentration expressed in molarity, capital M, moles per liter. How do you do that? 108 is the quantity of glucose. Then you have the molar mass of glucose. It is given to be 180.2 grams per mole. So convert the number of moles of glucose, convert the number of grams of glucose to equivalent number of moles. 108 divided that by 180.2 is 0.599 or 0.6 moles of glucose. Since the volume is already given in liters, no conversion is necessary. You have 2 liters. So, but 0.599 is dissolved in 2 liters. So simply divide 0.599 or 0.6, divide that by 2 to give you an answer of 0.3 capital M, 0.3 molar solution. Again, the trick here is numerator is expressed as moles of solute, denominator is expressed as volumes of solution. Okay. Now I think it's a turn for doing a reverse thing. What volume in milliliters of a 0.3 molar solution of glucose contains 0.025 moles of glucose? So of course, the concentration is given, the quantity of glucose is given in terms of moles of glucose. They're asking you to calculate the volume of the solution. Okay, so you know that the molarity concentration 0.3 is nothing but quantity in number of moles, divide that by the liters. So the volume liters, rearranging it, is going to be moles of solute, divide that by the concentration. If capital M is equal to moles of solute divided by the volume expressed in liters, if you're required to find capital V, the volume of the liters, it just becomes moles of solute, divide that by the concentration. So 0.025 moles per moles of glucose is the quantity of the solute. The concentration is 0.3 moles per liter. Moles and moles gets cancelled. The liter goes to the numerator. So 0.025, divide that by 0.3 gives you 0.083 liters of solution. And now I'm stuck again. Come on. Can't be doing this again and again. My God, for crying out loud. Okay, let's try this again. Okay. And then don't forget, they're asking you to find out the volume in milliliters, not in liters. So you just calculated the answer in 0.083 liters. Now you have to multiply it by 1000 to get to God. Again, I lost the internet here. Don't know what to do, man.
Yeah, I mean, honestly, I can follow along. Like,
do you mind? Because it's really it would be a huge help if you can follow along on the slide deck, and then I can just tell you which slide number I am, but the problem is it messes up the recording though. I really apologize for
Like I
the
said,
dynamic.
it's okay. I've had problems too. I'm gonna have to kind of go over these slides as I do my homework anyways, because I mean it's pretty fast paced, and like I said last time, I got to be the one to put the pencil to the paper to really
Understand.
make sense. So
Okay, no, I appreciate your patience. So this is what I was saying, convert that liters into milliliters by multiplying it by 1000 to get 83 milliliters of glucose solution. Okay. Okay, yeah, this is not working for some reason. This slide deck is absolutely not working. Not able to convert it. Let me just hit pause. Let's take a 5-minute break. I'm going to try to use another device here, and let's see if that works, if you're okay with it.
okay, no, sounds good.
Let's take a 5-minute break. I'll just pause, actually keep the recording going. I'm just going to go and see if I can get a different device.
Okay.
Okay.
All right, I'm back.
I'm here, but now I've got this thing. Now I'm not able to share my screen. My God, this is so frustrating, man. Let's try one more thing here.
Short of pointing your phone at your screen, right?
Yeah, that is. And we are more than halfway through the class, so thanks for enduring, man. This is
That's what.
I got my work laptop and I got my tablet, which I thought would get the job done, but unfortunately that is not going according to script. Okay, I'm gonna try it one more time now. So let me close this at 9:2.
Well, this is going better than my other classes, so.
Thanks for being so gracious.
I wish you taught digital design.
I'm teaching. I'm gonna be teaching Introduction to Engineering.
Oh, God, I hope I get you.
Have you taken that one?
No, I don't think so. Or introduction? Yeah. Yeah, they sent us a bunch of stuff and like a MIDAC and like a bead board.
Oh yeah.
and all that junk, and it's frustrating trying to get the thing to work because you got to download the software, and so
I know I've been warned about it, so I don't know what I'm going to be doing, to be perfectly honest with you.
yeah. Now you'll be dealing with a bunch of angry students that
Oh boy.
mine's not working.
Why is my Zoom not working now? Come on, you're supposed to automatically sign in, buddy. Okay. Oh man. This is very frustrating today, to be perfectly honest with you. And all because of my Okay, I'm gonna try one last time. Otherwise, I'm gonna give up.
That's okay. We got through a bunch. Like I said, I'm gonna have to go through these slides with my homework.
Yeah.
So.
Let's try it one last time. Otherwise,
I'm just glad you have slides. My other classes don't.
I have Zoom. Why is this not opening up? That's what I don't understand. I have Zoom open here. See, now I'm logging in, but where is the meeting ID? Do you know how to find the meeting ID in Zoom?
I do not. You want me to just back out and come all the way back in, or like if you have to close it all out?
No, don't do that, because it's Maximum participants, video, no, if I can find the meeting ID, I can put that in the thing. Security, lock meeting.
Let me go to meeting times. Yeah, I think the host is the only one that sees that.
Really?
Otherwise I could invite people that don't belong or something.
Yeah, that makes sense, but when I have the app installed on my machine. This is not what I want. Just need the meeting ID, which I'm not able to find here. It won't open it. It won't let me sign in. And it is not letting me. I have Zoom logged into my machine. Okay, let's try it one more time. Gonna do something else now. Okay. Now let's try to go in here. Okay. Please, please, please. Okay, buddy, I give up. Nothing's working here.
Yeah, that's okay. It's an early day.
Okay, so what is the solution now? No pun intended for solutions chapter.
Well, it could just bleed, the lesson could just bleed on over into nuclear chemistry.
I'm just thinking now because I mean, I get back into town only on Wednesday, so I'm gonna have the exact same issue for next Tuesday's class. I hate to do this, but I mean, would you be open to doing a quick makeup class on, so I'll give Tuesday off to you for chemistry. And we'll start acids and bases on Thursday, and then can we finish it up on next week on Friday or Saturday? Would you be willing to do that?
Yeah, like Mondays and Wednesdays I have double classes, so I'm in anything else I'm okay with.
Yeah, I'm really sorry, Drew. I
That's
hate
okay.
to do this. But so next Tuesday, you don't have a class. Let's proactively cancel the class next Tuesday.
Okay.
And then we'll start acids and bases on Thursday. Okay. And then I'm going to request you for one makeup class on Friday or Saturday, so we can make that final determination on Friday, or sorry, on Thursday. When do we want to make up our makeup class?
Whatever's easiest for
Yeah,
Big
yeah.
deal.
So we'll make up. I mean, if Brian's there, we can also ask him. Otherwise, we'll just go with whatever you prefer. I can make it either on Friday or I can make it on Saturday.
I'd probably prefer a Friday because the weekends are always, it's my wife's birthday this weekend, so
This weekend? No, it's not this weekend. It's the next weekend.
next weekend.
Yeah.
Yeah, I'm up for whatever.
Okay. So let's make the final call on Thursday then. Next Thursday. Okay. So tonight's class is like a chaos. I mean, we got through half of chapter. So what I will do is on Thursday, next Thursday, basically a week from now, because next Tuesday, October 11th, we will not have a class. Okay.
Okay.
So on October 13th, we will finish up the chapter on solutions. Okay. And then we'll start acids and bases and then see how much we can go through on Thursday. And then we will have one makeup class and just finish it up. And then we'll be caught up.
Sounds good.
Okay. Okay. I really appreciate it. And thank you again for your understanding and sorry about the chaos.
Yeah, no worries. Yep. Have a good vacation or whatever.
Yeah, it is supposed to be a vacation, but I was hoping to still make it seamless, and I don't think it worked out.
Yeah, no,
Things can be
Okay.
worse. Yeah, so I promise I will keep it simple for you on Thursday.
okay, sounds good.
Take care, buddy.
All right, man. Bye.
Bye.